In this video, we will be discussing question number 59 from Chemistry Gate Exam 2022. So, in this question, the state of the electron in a helium ion is described by the following normalized wave function psi r theta phi. And if the energy of the ion in this state is measured, then what could be the probability of obtaining the energy of minus 2 by 9 atomic units? And this wave function is represented in terms of radial components r and angular components y. So let's see how to solve this problem. So it's given that for helium ion, psi r theta phi is equal to this, where psi is represented as a combination of three different wave functions having a radial part and an angular part. So psi NLM can be represented as a combination of r NL, which is a function of r, and YLM, which is a function of theta and phi. Here, these N, L and M represent the quantum numbers: principal quantum number, angular quantum number and magnetic quantum number. So this equation can be simplified to this form: psi r theta phi is equal to root 3 by 8 psi 210 minus I root 7 by 16 psi 100 plus x psi 320. So the n value, L value, M value here is 210. This is obtained from here. The n is equal to 2, L equal to 1 and M equal to 0. So here n value is 1, L equal to 0, M equal to again 0. And for the third part, n equal to 3, L equal to 2 and M value is equal to 0. So we obtained this form of this equation. At this stage, we'll go back and see the question once again. That is, probability of obtaining the energy of minus 2 by 9 atomic unit. So what is actually the probability is? That is, the probability of finding any observable. Here the observable is energy in a particular state, that is the square of the corresponding coefficients. So here we have three coefficients: root 3 by 8 minus I root 7 by 16 and x. So we have to find out which coefficient will give the square as the probability. So we'll see what is the equation for energy of a helium ion. Energy equal to minus Z square by 2n square. For helium, Z, which is the atomic number, is equal to 2. So energy will be equal to minus 2 by n square. This indicates that energy depends only on the quantum number n, neither L nor M. And also in the question itself, the energy is given as minus 2 by 9. So we can equate these two, that is minus 2 by n square is equal to minus 2 by 9. So the value for n comes up equal to 3. So here in this equation, for the first part, this is NLM order. So the n value is equal to 2. For the second part, n value equal to 1. And for the third part, n value equal to 3. So we obtained the energy is corresponding to n equal to 3. So the probability will be square of the coefficient, and the coefficient will be x, and the probability is equal to x square. So now we have to find out the value for x, because x is an unknown quantity. For that, we have to consider another equations where we have represented psi as a linear combination of hydrogen-like wave functions. And psi is a normalized wave function. So, the squares of the coefficients root 3 by 8 minus I root 7 by 16 and x must be equal to 1. So on solving this equation, we will find out what is the value for x. So for solving this equation, we should know that the multiplication by complex conjugate, because this is an imaginary part. So we are multiplying this with the opposite signed complex conjugate and we'll get the answer x square equal to 3 by 16. So this is the probability of finding an energy that is minus 2 by 9. So the answer for question number 59, the probability of obtaining the energy of minus 2 by 9 atomic unit is 3 by 16, that was x square. For more details, you can go back and check NPTEL lectures, Postulates of Quantum Mechanics 1 by Dr. S. Lakshmi Bala, Department of Physics, IIT Madras. The YouTube link for the same is provided here. Thank you.